Hello. So, in this video, I'd like to introduce the so-called curse of dimensionality. The example I am going to introduce this with is called a document vector. And a document vector is just a vector storing how many times a word shows up in a document. And let us play a game. Let's count, let's take two books, two real books, and let's count the number of times these words show up in them. All right. So here is one of the document vectors. So alibi 8 times, detective 29 times, embrace 0, kiss 0, and so on. And here is another document vector. Bear with me. So alibi 0 times, detective 0 times, embrace 3 times, kiss 15 times, and so on. So here is the game. One of these vectors represents a novel called The Hollow Man, a 1931 murder mystery by John Dickson Carr. And the other document vector represents Ravish, a 1991 romance novel by Amanda Witt. So, can you tell which vector comes from which novel? I swear, not a trick question. The Hollow Man is a murder mystery. And all the words you'd expect in a mystery, like alibi and detective, show up in it, whereas words you'd expect in a romance novel do not show up in it. Ravished is a romance novel. All the words you'd expect in a romance novel show up in it, whereas words you'd expect in a detective novel do not show up in it. Pretty clear, right? What if we made these document vectors longer? So now we've got detective novel words, we've got romance novel words, and we've got just sort of random words like cat and coffee. Well, our intuition is maybe that more data should be good, but really, a lot of this data is irrelevant distraction. If our goal is maybe to classify a novel by genre, it's probably not very helpful to know how many times the word cat shows up in it. And then a real document vector, containing every word in the novel, might contain 15,000 entries, and most of those entries don't matter. They are distracting. They are noise. So what we would like to be able to do is take a document vector like this and reduce its dimension. Instead of having 15,000 entries, we want to whittle that down to 10 entries or 100 entries maybe, but much less than 15,000. And there are a few ways we can do that. In this class, we select one of them as kind of a representative example. And that representative example is called principal component analysis. So throughout the rest of the week, we'll talk about this. We'll see how to do it in Python, and then we'll see how to do it in Spark using Databricks.